All right, we're looking at the Unit 3 test review. I don't know what that was, but it sounded awful. Oh. Oh. All right, don't cross your legs. Here we go. So we got the cosine of 5x plus 12, or 5 pi, excuse me. Come on, Dave. 5 pi over 12. Things that are divisible by 12 that add up to 5. So let's go with 3 pi over 12 and 2 pi over 12. I won't want to do 1 pi over 12 because 1 pi over 12 does not reduce. And again, we need pi over 6, 4, or 3. So 3 pi over 12, that's going to get us pi over 4. 2 pi over 12 is a pi over 6. So we are going to use the cosine sum. Cosine sum. So theta plus phi. Is that right? Phi. So cosine minus sine. All right. So cosine pi over 4 cosine pi over 6 minus sine pi over 4 sine pi over 6. Cosine of pi over 4, we got root 2 over 2. Cosine of pi over 6 is root 3 over 2. Sine of pi over 4, root 2 over 2. Sine of pi over 6, that is 1/2. So we get root 6 over 2 minus root 2 over 2. No. No. Across the top, across the bottom. Final answer is root 6 minus root 2 all on 4. Sine of negative 15, I got you. That's going to be the sine of 30 minus 45. So sine subtraction, so the difference, sine difference. Sine cosine minus cosine sine. All right, so that means we have the sine of 30 and cosine 45 minus the, what do we say? Cosine 30 and the sine 45. Sine cosine minus cosine sine. Sine cosine minus cosine sine. Okay, great. So sine of 30 is 1/2 cosine 45 root 2 on 2. Cosine 30 root 3 on 2. Sine of 45 root 2 on 2. Yeah, same story, right? Root 2 over 4 minus root 6 over 4. Final answer, root 2 minus root 6 all on 4. All right, tangent of 110 minus tangent 120 all over 1 plus. Okay, so that, since I have tangent minus tangent in the numerator, I'm going to be using the angle difference formula here. So that looks like we're going to get the tangent of 110 minus 20, which is the tangent of 90. So that's sine 90 divided by the cosine of 90. The sine of 91, cosine of 90, 0. And girlfriend, you can't do that. All right, with this one here, we have the tangent plus. So tangent plus right here. So I'm going to be adding. This is all going to turn into the tangent of negative pi over 9 plus 4 pi over 9. And that gives us the tangent of 3 pi over 9. That's the tangent of pi over 3. So the sine of pi over 3 divided by the cosine of pi over 3. The sine of pi over 3, what's that? That's our root 3 over 2 divided by 1/2, which is root 3 over 2 times 2 over 1, which is root 3. Final answer. All right, so this one's a double angle formula. Use a double angle formula to find this stuff. Okay, so double angle tangent here, right? That's 2 tangent 35, 1 minus 20. Okay, so this all turns into the tangent of 2 times 75. So the tangent of 150 equal to the sine of 150 over the cosine of 150. So that is 1/2 divided by negative root 3 over 2. So 1/2 times negative 2 over root 3, which is negative 1 over root 3. After you rationalize, so let's do that here. We get negative root 3 over 3. 2 sine cosine. Which one are you? 2 sine cosine. That is a sine right there, girl. So that is the sine of 2 times 112.5. Love me some decimal work. All right, so 225, is that right? So the sine of 225, that's quadrant 3. That's the 45-degree angle in quadrant 3. So that is going to be a negative root 2 on 2. Cosine squared minus sine squared. What on earth are we doing here? We have a cosine squared minus sine squared. I don't have that anyway. Cosine squared minus sine squared. I don't see it. I don't see it anywhere. But I do have 1 minus 2 sine squared, or I have 2 cosine squareds minus 1. So let's do this. Cosine squared minus sine squared. If I take sine squared, subtract the cosine, right? So sine squared would be 1 minus cosine squared. That sine squared. So I have cosine squared of 7 pi over 8 minus 1 minus cosine squared of 7 pi over 8. And when I distribute that, right, I'd have a minus 1 and then minus 2 cosine. So I have, sorry, plus cosine, right? Let's distribute. 7 pi over 8. I don't want to get messed up. Minus 1 plus cosine squared of 7 pi over 8. So I have 2 of those, right? Which looks like this, right? 2 cosine squared. 2 cosine squared minus 1. I have 2 cosine squared 7 pi over 8 minus 1. 2 cosine squared theta minus 1. So that's cosine of 2 theta. So all of that is cosine of 2 times 7 pi over 8. And that's 2 over 1. That 2 is going to reduce. So we're left with the cosine of 7 pi over 4. Ah, I can do that. That's quadrant 1, 2, 3, 4. Quadrant 4. Yeah, quadrant 4. That's a positive root 2 over 2. Sweet. 1 minus 2 sine squared. Hey, girl. 1 minus 2 sine squared. I already got you. Cosine of 2 theta. So this is the cosine of 2 times negative pi over 12. Yeah, sorry for all the extra parentheses there. That 2 is going to cancel with that 12. So we're looking at the cosine of negative pi over 6. Cosine of negative pi over 6. Again, go back in quadrant 4. We're just going down, right? Quadrant 4, we're going down to pi over 6 here. I'm looking for my x value, which is the long side of the 30, 60, 90. So we're looking at root 3 on 2. Okay, use a half-angle formula to simplify this expression. Got it. That's you, right? 1 minus cosine over 2. 1 minus cosine over 2. Tangent of y over 2. So this tangent of theta over 2, right? And so we get tangent of y over 2. Okay. As far as I can take it. We got the square root. Oh, that's the cosine. Oh, I don't like that. I don't like that. 1 minus cosine of 3. 1 minus cosine of 3 pi over 2, and I square root that. So that's sine, right? That's going to be a sine of the angle. 2 theta to theta. Let me just be really clear what that is. What this guy's saying right here, saying that the sine of theta equals plus or minus the square root of 1 minus cosine 2 theta over all over 2, right? So we got a pattern match. My 2 theta is equal to 3 pi. 2 theta is equal to 3 pi. And if I solve for theta, dividing by 2, theta is going to be 3 pi over 2. So all of this simplifies to sine of 3 pi over 2. And the sine of 3 pi over 2 is just negative 1, right? Cool. 1 minus cosine of 200, 1 plus cosine of 200. What? Hmm. So if I take 1 minus cosine theta over sine theta over 1 plus cosine, if I take these two and I divide them, nope, that's just 1. All right, tangent theta over 2 divided by tangent theta over 2 is just 1. This whole thing is just 1. I don't know why I'm going to do all this. I don't know why I have to do this. All right, so I'm not going to put this on a quiz or a test, so let's just ignore him. The algebra is not too terribly difficult, but why I get there is dumb. Manipulating this for tangent and hat theta over 2. I don't like it. We could do this one, though. This one says a cosine, 1 plus cosine 2 theta over 2. 1 tangent over 2. That's this guy right here, cosine. So if I take 10x and I let that equal 2 theta, and I divide by 2, then theta equals 5x. So all of that gives me cosine of 5x. That's all I need. Okay. So use both the half angle and the sum formulas to find the exact value of sine of 75. In other words, show that sine of 150 over 2 equals the sine of 30 plus 145. Okay. Okay. So let's go to our half angle. You're annoying, aren't you? Our half angle. I really wish that they didn't do this. So on your notes, you should probably have something that looks like this. I'm going to use this space here since I'm not doing this. The half angles that say the sine of theta over 2 is equal to plus or minus, right? That just means we're paying attention to what quadrant we're in, the square root of 1 minus cosine theta over 2. So there's your half angle identity. Then we have cosine of theta over 2 is equal to plus or minus the square root of 1 plus cosine theta over 2. That's just the same way of saying these half angle identities here. All right. Now, something gross about what we're going to do here, but the sine of 150 over 2 is equal to, what quadrant would we be in? So 75 is in the first quadrant, so our sign is going to be positive there, so I need the positive. 1 minus the cosine of 150 all over 2. All right. And then on the other side, we got the sine of 30 plus 45. Sine of 30 plus 45 is this guy. So that is the sine of 30 plus 45 is sine 30 cosine 45 plus cosine 30 sine of 45. Sine cosine plus cosine sine. So sine 30 cosine 45 plus cosine 30 sine 45. There we go. All right, let's finish this guy over here and see if we can manipulate him to get to look like it. Sine of 30 is root 3 on 2, cosine of 45 is root 2 on 2, plus cosine of 30. No, yeah, no. I made a boo-boo there. The sine of 30 is 1/2. The cosine of 30 is root 3 over 2. My bad. Root 2 over 2. So cross top, cross bottom, we get root 2 on 4 plus root 6 on 4. All of that is root 2 plus root 6 on 4. All right, so does this turn out to be this guy? Only one way to find out. Cosine of 150. So cosine of 150 is negative root 3 over 2, correct? I'm 75% positive that's true. 150, that is this guy here, negative root 3 over 2. Yeah, all right, so square root 1 minus negative root 3 over 2 all divided by 2. So that's 1 plus, well, 2 over 2 plus root 3 over 2 all divided by 2 over 2. The whole thing is taking the square root of the whole thing, which I don't know that we're going to be able to show this. I don't know the algebra to make that work. So this is probably a terrible question. And that's okay. So we get 2 plus root 3 over 2 divided by 2 over 1. Or we can do this. 1 over 2. Keep change flip, right? The whole thing is square rooted. So our final solution is square root of 2 plus root 3 all on 4. Are these equivalent statements? I kind of wonder. Let's see. Square root 2 plus root 3 all divided by 4. Mm. No, no. Huh. I wish I knew the algebra. Neato burrito. I don't know the algebra to get us there. Sorry, dude. But that's cool. Uh, my suggestion is to ignore this problem altogether because you will not see that on a test. All right, here we go. Given that A is in the first quadrant, the sign of A is 12 over 13. So A is in the first quadrant, and the sign would be 12 over 13. And if I do my Pythagorean, I get that 5 right there. All right, so that means that the cosine, there's my theta, so cosine of A must be 5 over 13, and tangent of A is 12 over 5. So now we can go find the sine of 2A. So the sine of 2A is 2 sine A cosine A. And sine A, it tells me, is 12, 13. All right, so 2 times 12 over 13. And the cosine of A was 5 over 13, so 5 over 13. And now we just multiply cross top, cross the bottom. So 2 times 5 is 10, times 12 is 120, 13 times 13 is 169. So 120 over 169. Cosine of 2A. So cosine of 2A is 2 cosine squared minus 1. So 2 cosine squared A minus 1. Cosine A is 5/13, so 2 times 5/13 squared minus 1. 5 squared is 25. 25 times 2. So we get 50 over 169 minus 169 over 169. 50 minus 169, I believe, is a negative 119 over 169. Wheat. Yeah, cosine of 3a. Yeah, I don't like that. But that is the cosine of a plus 2a. So why am I doing capitals and lower cases? I hate that, so I'm going to keep mine all capitals. So now we got to go as sum. Here's our sum right here. So cosine of theta plus phi. So cosine minus sine sine. So cosine A times cosine of 2A minus sine of A times the sine of 2A. And now we got our double angles in there, right? So sine of 2 theta is 2 sine theta cosine theta. All right, that's that guy. Cosine is 2 cosine squared minus 1. So starting with cosine A, we know is 5 over 13. Cosine of 2A, which we just saw, is negative 119 over 169, minus the sine of A, which we know down 12 over 13. Oh, the sine of 2A, we already did all that work. That's 120 over 169. And I might be handsome, but I'm not that good looking. Here we go. So 5 over 13 arrow times negative 119 over 169 minus 12 over 13 times 120, 169. All of that to get, oogie golly, all right, so we get a negative 2035 LLZ over 2197. Ugly as it could be, but it works. tangent of A over 2. All of that to get to this next number. All right, tangent of A over 2, so tangent half angle 1 minus cosine over sine. 1 minus cosine A over sine A. So we get 1 minus 5/13 divided by 12/13. I'm going to get like terms here so I can get myself to a keep change flip, right? Common denominators, not like terms. Sorry. So we get 13 over 13 minus 5 over 13 all over 12 over 13. So 13 minus 5, we get 8 over 13 divided by 12 over 13. So 8 over 13 times 13 over 12. 13's cancel. Woo! 8 and 12 both reduced by 4. So that gives me what? 2/3. My final answer there. Pretty good. All right. Verifying identities. Here we go. This is it, right? Oh, good. All right. So, this guy, obviously, the left side has more work to do than the right side. We're going to get ourselves a common denominator. So I'm really going to give myself some space here. Common denominator, I'm multiplying here, right? So 1 minus cosine x times 1 plus cosine x. 1 minus cosine x times 1 plus cosine x. So that means I need in my numerator, I've gained 1 plus cosine x. Over here, I've gained 1 minus cosine x, right? And when we add those together, I have 1 plus 1 cosine minus cosine. So we end up with 2 over common denominator. So 1 minus 1 plus, that is 1 minus cosine squared x. Thinking about our difference of perfect squares, right? Conjugates. So 1 minus cosine squared is sine squared. So we get 2 over sine squared x. And sine squared x is 1 over sine squared. 1 over sine squared is cosecant squared. So then that gives us 2 cosecant squared x. That's what we wanted. I shouldn't have put my equal sign. I should have just kept going down. My bad on that, dog. Here we got a secant minus tangent times sine. Okay, gross. There's nothing in common, right? So secant, tangent, sine. If there was something in common here, I would try to factor it out if I could, but I don't have anything in common right there. So secant in terms of sine, secant is 1 over cosine. All right, so 1 over cosine x minus tangent, which is sine x over cosine x, times sine x. I see what you're doing here, girlfriend. Multiply that, right? So sine squared, 1 minus sine squared all over cosine. 1 minus sine squared all over cosine. Got a common denominator, right? Well, this fraction and this fraction have a common denominator, so I can combine my numerators. 1 minus sine squared is cosine squared x over cosine x. One of those cancels with the denominator, and we get cosine x. Cosine is 1 over 2. So that checks out. Cool. 2. Right, 2 more. We can do hard things. Left side. Do the left side. And not only that, but here's what's cool. Cosecant and cosecant. I have a binomial divided by a monomial, right? X minus y over x. I have a binomial divided by a monomial. That turns into x over x minus y over x. Right? I can split that up when I have a monomial in the denominator. So I get cosecant squared x over cosecant squared x minus 1 over cosecant squared x. Not a problem. Cosecant divided, that's 1 minus cosecant, 1 over cosecant, 1 over, oh, there you are, is sine. Great. So 1 over cosecant squared is sine squared x. 1 minus sine squared x is indeed cosine squared x. That's your Pythagorean identity. Sweet. All right. Ew. Ew. Now, I could go several ways around this. I can get a common denominator, combine like terms, do the whole thing. Or I can turn everything into sine and cosine, and hopefully it pans out. So what I'm going to do is go with sines and cosines. My theory on this is that everything will simplify to that's sine and that's cosine, but we shall find out. Tangent, we get sine theta over cosine theta. Secant, and you are 1 over cosine, all right? So we get 1 over cosine theta plus cotangent is cosine theta over sine theta divided by cosecant, which is 1 over sine theta. Keeping and changing and flipping. So sine theta over cosine theta times cosine theta over 1 plus cosine theta over sine theta times sine theta over 1. Hey, let's go. Sine theta plus cosine theta. That's all she wrote.